This is the second part of a lesson on composite functions. We're going to look at two things in this lesson. First, numerical composite functions, and secondly, decomposing composite functions into the component functions. So a numerical composite function is a function that occurs with no equation, only data, like this data table. So what we're given in this situation are a series of domain values, corresponding values for some function f, and corresponding values for some function g. But other than that, we're not given a definition of f or g. This would comprise what's called a numerical function. So I'm going to work through a couple of problems associated with this. Basically what we're going to do is we're just going to refer to the chart and use the definitions of what composition is. So first up, when we look at f of g of 2, well, what we first look at is g of 2. And we find that g of 2 is the value -1. So this is actually equivalent to the result, -1, substituted into the outer function f. Remember, f of g like this means the function g is put into f. So f of g of 2 means find g of 2, get the result, put it into the function f. Again, g of 2 is -1. So I need to find now f of -1. I need to go back to the chart at -1, find the value of f. The answer to this is 1. Alright, I've done one for you and explained it. If you need to, go back and get a refresher. Otherwise, pause and try the next one and see how you do. Okay, the next one. This time f is the function put into g, and it's evaluated at 2. So I want to start by finding f of 2. f of 2 is 0. So what I'm doing ultimately is finding the result of substituting 0 into g. 0 in g gives the result -2. Alright, if that was a struggle for you, you might want to go back and listen and try again for part A and part B, look for the patterns. I'd like you to move ahead and try both C and D now, pause it, and then come back and see how you've done on these. Alright, well, next up, I first want to find, oh, I've gone a little too far, you need to see that chart. I want to find g of 0. g of 0 is -2, so this is about finding the value f of -2. That is the number 1 from right here in the chart. Next one, g of f of 0 means find f of 0 first of all. That's the number 3 right there. So this is about finding g of 3. g of 3 is the number 0. There we go. So that's numerical compositions of functions. Now, decomposing composite functions. Sometimes you're given a composite function. You might not even be aware that it is a composite function, because composite functions are just functions. But they may be comprised of a function that's input or inserted into another function, thus a composite function. What you do to figure out these types of functions is consider the input function to be some function g, and then imagine that the other function that it's being put into is the function f, so that taken together you get the composite function that we'll call h, which is f of g of x. So again, we're trying to see what function is inserted into another function. It's a bit of a visualization exercise, so let's do a bit of practice on this. In example 5, I have some h of x values given. I didn't write h of x, let me clarify that here. h of x equals. So these are some h of x functions, and we need to figure out what might be inserted into what else, function into function, so that we get a composite. Well, looking at this one, I see an x plus 5. x plus 5 itself is a function. So I could say g of x is x plus 5. Now, that whole function is inside of a square root. Square rooting is a certain operation or a rule or a function. So I could say that there is a function f that is a square root function with input. And we see that if I put x plus 5 into the function f, that would be the square root of x being replaced with the input of x plus 5, which is what I want. That's the composition function. So that's my h of x, given this g and given this f. All right, try the second one by pausing and giving it a try, and then come back and rejoin me. Okay, hopefully you've done that. I recognize that there is a cube root of x plus 1, and I see that on 2 occasions here. And so I'm going to say, well, let's let g of x be that cube root function x plus 1. It is being squared, so something is being squared, then it's being just added on afterwards, so something being added on, and then there's the number 7 being added on. If I call that a function f, look and see that the substitution of g for every value of x produces the composite function that I have. So again, f then of cube root x and 1, which is g, would be cube root of x and 1 squared. So far so good. Cube root of x and 1, good. And then 7 added on. So that's it. I'm going to leave you with a challenge. And here's the challenge. I give you a g function in some cases. In some cases I give you an f function. And in each case I'm giving you the composition of functions. So you know what the composite function is, and you know something about how it was formed. I'd like you to figure out what the question marks are in order to get everything matching up with a g and an f making an f of g. Good luck.